Hello everyone, today I'm going to show how you can improve the performance of AWS API Gateway. These two techniques are incredibly powerful in terms of performance tuning. If your API is running slow, just these two techniques are giving significant performance improvement. Mainly I'm going to talk about and show in the demo these two techniques. The first one I'm going to talk about, which is compression, and the second one is caching. Before I start, please like and subscribe if you like this content. It would be really appreciated. And furthermore, if you have any comment or thoughts, please comment below. I'll get them as soon as possible. Let's get in. Let's start with the first technique, which is compression. AWS support mainly three types of compression method. The first one is a deflect. The second one is a gzip. The third one is a identity. When you call API gateway, you can mention the compression method in your header. So as you know, we do have a method, something called accept-encoding. In the accept-encoding, you can mention, okay, what your preferred compression method. Based on the request header, AWS compress the content and send back to the client, or in this case you. So we will see this in a demo right now. Right, I'm in AWS console. Let's create a sample API gateway with the sample lambda function. Search API gateway, click on API gateway, and then click on create API. As a API type, we are going to select the third option, which is REST API, public REST API. Let's give it a name. So I'm going to create a new API as the name as let's say demo performance API. Keep all the setting as it is. Click on create API. Right, our API got created. Now we're gonna create a resource. Click on the resource. Give it a name as users. And then let's create a method. Select the method type as a get. And as an integration point, integration type, we select the lambda function. We will select a lambda function. Already I do have I create a lambda function. Let me quickly show the lambda function and what does it do. This is my lambda function, which got created, already got the code, and this is Node.js runtime. It's running on the Node.js runtime. The lambda function is very simple. It just responds with a JSON content. This JSON content, as you can see, this is a response. Response go with the status code 200 and some payload. The body is some payload with the JSON string file. If you show the JSON sample JSON payload, which is if I expand, this is a little bit big payload with this type JSON in a JSON format. Now we go back to our configuration and select this demo API performance. This is our lambda. Select all the setting as default and click on create method. Right, so we create the method with the get. Now let's deploy these changes to staging environment. Click on the deploy API, and currently we don't have any environment. What we're gonna do, we will give it a name as without compress. So we will create a different environment with compression and without compression, so that we can compare the response time and the size of the data transfer from server to a client. Let's deploy. Right, so now our endpoint is ready. What we're going to do, we will see how this endpoints work and what's the time is taking and what the size is transferred from the server. Click on the get method and click on invoke URL. Copy the invoke URL and go to your favorite browser. I'm using Firefox. and hit enter. I'm open developer console and click on the network tab. So there, this is where you can see all the data, and give it a refresh. But you can see the status cost with the 200, that is our request, and what you can see transferred and the size, both two columns are 831 kilobyte, and the time is took about 556 millisecond. So this is without compression. Let's give a refresh again to make sure. As you can see, it's still transferred and size is same, and it took 549 millisecond. Now it's time to enable the compression. Let's go to our API again. Go to the API setting of our API, and then click on under API details. You can see the under API details, click on edit. Then what you can do, if you quickly go through here, this is where you need to enable the compression. Its name is content encoding. So once you click on, you have to specify the minimum body size. If you set to this to 0, then all the requests will be compressed up to 10 MB. The maximum load is, as you can see, maximum threshold is 10 MB. Any content more than 10 MB will not be compressed. Let's set to 0, which will enable all the content into compress. All the content will be compressed up to 10 MB, and click on save changes. Right, our changes is saved. When the compression is enabled, you need to deploy the changes to staging. Otherwise, the new change will not be affected. So what we can do, we will deploy these changes to new environment. So we do have an environment without compressed. We will create a new environment. This one we call it with compress, so that we can compare the both environments simultaneously. Deploy. Right, now we do have a two environment, but API it's both getting the data from our lambda function. But very first one with the compress, the second one is without compress. Let's go to with compress and click on the get and copy the URL. Now let's compare without compress and with compress. Right, let's copy the URL for the compress one. I'm click on the compress get and get the invoke URL. Open a new tab, enter, and open the developer tool, click on the network tab, and then again give a refresh. So right, cool. So what you can see, I'll get the side by side, so you can see both what's gonna happen. Right, so basically what I do, I get the side by side, so you can see both simultaneously. The one that in the from I'll get the again network tab, give a refresh. Right, so the one that in the top window, which is without compress, you can see this is without compress. The one that in the down with compress, as you can see the transferred and size. Basically with the compress, the size is still same, which is 831, same as without compress, but the transferred, it's drastically reduced. You can see it's almost reduced, like almost 4 times it reduced. This is a 280, the actual size is 831. So actually data transferred very less, because it's compressed the data and passed to the client. And as you can see the time, so this one it's reduced, this one is a 549, this is the 356. If I give a refresh, let's see, okay, you can see there is 340, but it's reducing compared to the without compress, and this time you can see 235. It's reduced like a 200 to 300 milliseconds in this scenario. That's a big significant improvement. So if the page your content is the larger, let's say you have a 2 MB, 3 MB, 5 MB, this is get a lots more significant performance improvement. Right, if I recall our compression, we need to send a certain header in as a client. So if I click on the our get request, and if I go to our request header, and what we set accept encoding as a gzip, deflate and br. So we mentioned as a client gzip is our preferred method for the compression. Then what does the AWS says, okay, he saw this header, and based on the header it compress the content and send back to the client. One thing is if you do not send the accept encoding, even though the API support compression, we enable the compression in a server side, you won't get the data in a compressed mode. So what we can do, we can send this same request without header and with header. Let's have a look. So basically I'm open Postman and just click on the create new request and paste the same URL. And the header, what you can see, this is a default header usually Postman sending, and currently sending the accept encoding. So we will try this one first. As you can see, size is 230 because we are sending the encoding as this one. If I see the same endpoint without sending this header, I'm unclick this accept and encoding. See the size. What you can see, it's a size is drastically increased. It's a 4 times increase, and the same time it's a time is increased because we need to take more time to download the bigger file. So that's why I said you need to, if you want to enable compress, you need to enable the compression in the API gateway, and as a client, if it's the front-end application, you need to send this accepted encoding and whatever your preferred method. So then you get the smaller size, the compression content get as a compress. Right, that is how you can improve the performance of API gateway using compression or content encoding. So AWS call it content encoding. Note that if the content size is very small, like a few kilobyte, it is good to avoid compression, as a compression itself add a bit of overhead. But for the bigger responses or bigger payload, definitely you will get a better performance. So that it's about the compression. So let's check how we can further improve this same API with the caching. Now let's see the second way to improve performance, which is using caching. You can enable the caching in AWS API Gateway to cache your endpoint responses. With the caching, you can reduce the number of calls made to your endpoint and also improve the latency of requests to your API. It improves the response time while it's saving the cost. When the client requests a content from API Gateway, the API Gateway checks the cache first. If the content is not in the cache, then it goes to the integration point. In our case, it's a lambda. So it gets the response from the integration point. Then it does two tasks. The first task is it sends the response back to the client as client requests the response. And the second one, it saves the response in API Gateway cache. With that, the subsequent requests are served from the API Gateway cache rather than calling the integration point. However, based on the TTL stands for time to live settings, the cache is expired after a particular value. The default TTL value for API caching is 300 seconds. The maximum TTL value is 3600 seconds. That is almost 1 hour. There's one consideration when you're using cache. The maximum size of the response that can be cached is almost like a 1 MB. If you want to if your response is more than 1 MB, then the caching won't work. So please make sure when you enable the caching, so the response is less than 1 MB. Right. Now that's about the theory. Let's check how does this caching work in action with a demo. Right. I'm back in AWS console in the same API we created for demonstrate the compression. So the caching can be enabled for stages and specific method level. We will use the same API endpoint to demonstrate the caching. Let's do before a quick code changes in the lambda to pretend the lambda take a few seconds to process the request. I'm go to a lambda, the existing lambda. What I'm going to do, I'm importing exec_sync from the child process, which help me to create a sleep. So as you can see, using the exec_sync and passing a sleep 3. This what does it do? It's post the execution to 3 seconds. If I send a 2, it's post a 2 second. The everything else it's same as my earlier code base, nothing changed. The only it's sleep 3 seconds. Let's deploy. It's deploy already. Now let's come back to our API gateway, and what we're going to do, we will create a few staging environment. So for example, we will create a first environment. We will call it is without cache. Let's deploy and go back to resource and again deploy the same changes to with cache. Then we can differentiate the response time with and without cache. Right. Let's go to which cache staging environment. And as you can see, the cache cluster is inactive, and same time the default method level caching is inactive. That means we do not have a caching enabled for this environment with cache environment. So click on the edit and go to there's a section called cache settings. So enable the provision API cache. So as this indicated, as you can see, you need to enable a method level to enable the cache on API. Just enabling the provisional API cache will not enable the caching. So what we can do, simply you can enable, tick this mark, and default method level caching. What does it do? It's activate method level caching for all the get method in this stage. Then you can give the cache capacity. When enable the caching, AWS create a separate cache instance. The size of the instance affect the performance of the cache, which impact the API response eventually. So it is recommended to do a load test once a cache is enabled. Then you can adjust the cache instance size to tune up your API response time. And the next one is encrypt cache data. So if you have a compliance requirement, you can encrypt the caching data. Obviously, this will increase the size of the cache response. Then the TTL, the cache time to live. This will handle how long the cache is valid. After cache reach this TTL value, the cache is deleted automatically. The maximum TTL is 1 hour. Lastly, the per key cache invalidation. This is useful if the clients want to invalidate the cache and get the rest from the integration point. Let's say the TTL is not expired, but the client still need to get the real response from the integration point, not through the caching. In that scenario, the client can use this per key cache invalidation. In that case, the client should send a header, which is a cache control with the max age 0. And then, by the way, to perform this action, the client should have allowed with necessary IAM permission. I'm not covering this scenario in this video, but if you like to know more, please click the link in the description. I'll put the more details in the description. Right, and yeah, that's all about the settings under cache. let's save the settings. So one thing, once you save these settings, it could take 4 minutes to enable the caching for your API. So let's save the settings and see the progress of the cache. If I save it and go to cache, and what you can see, actual default method level caching is active, but the cache cluster is in create in its progress. So this is where it create the actual cache instance for this API. So it's take a couple of seconds or a couple of minutes based on the how busy the AWS. And once this is active and ready, we will come back and start a video again. Right, after a few minutes, our cache cluster is provisioned. So now the caching is enabled for this staging environment. What we're going to do, we're going to compare the response time for these two stages, the with cache stages and without cache stages. So let's get the without cache and go to a get endpoint and copy the URL. And then I'm opening Postman, and let's change without cache with this endpoint. So save it, and let's go to again, go to the with cache, go to get method and copy this URL, which is with cache. Save it. Right, so as you can see, we do have two endpoints with two endpoint which is pointing to two different environment. This is a with cache and this is without cache. Let's try with the without cache. As you can see, we do have a 3-second delay in the lambda. So altogether it's get like a 4 second and 24 milliseconds. If I try with the caching one, it's a very beginning, it's take a more time because it's need to, the first request always need to go to the integration point. And if you try that second one, if you click on again, you can see it's reduced to 107 milliseconds. If I go to without cache, I'm running on without cache a couple of times. So this is a 2 seconds subsequent request. Still let's get the 3 seconds. If I click on again, I'm in a without cache still. It's a 3 second and 65 milliseconds. And go to the cache one. Yes, it's a 140 millisecond. It's a huge difference compared with the without cache and with cache. Right, the performance improvement is almost 95% in terms of response time in this case. That is a huge win. Then what I can show you, I will quickly show you if you want to add a method level caching, how do we do that? So if you want to add a method level caching, go to particular method. In this case, let's go to our get method and click on the edit. And as you can see, the caching is enabled for this get method. You can customize the cache setting specific to this get method. That's how you can keep different cache setting for different method to cater your business requirement. Right, cool. That's it's all about how you can improve the performance of API gateway using the compression and the caching. So hope you enjoyed this video. If you have any comment or thought, please adding in the comment below. Again, it would be really appreciate your support. Please like and subscribe my channel. Really appreciate it. And then that is it for today. I will see you on another video. Thank you.